Edexcel Core Pure, second order differential equations, the homogeneous case. Finding particular solutions using boundary conditions. So now we're going to find our two arbitrary constants in our general solution using what are called boundary conditions. And this is information given about two different values of our independent variable. So for example here we're told that when x is 0, y is 0, and separately when x is 1, y equals 2. And these form 2 points on our solution, and these are called boundary points. And this kind of problem is called a boundary value problem. So this is the original second order linear homogeneous equation, and we have the boundary conditions when x is 0, y is 0, when x is 1, y is 2. We also know the general solution which we found in a previous video. So I'm going to use the first of our boundary conditions when x is 0, y is 0, and I'm going to put those into the general solution to get 0 equals a times e to the nothing, which is 1, plus b times e to the nothing, which is 1 as well. So there's the first of my simultaneous equations in a and b. But we also know that when x is 1, y is 2. So subbing those into our general solution, we get 2 equals a e to the 3 plus b e to the minus 5. Equation 2. Equation 1 could be rearranged to give me that b equals minus a, and I could substitute for b in equation 2 to find out what a is. It's a little bit fiddly, but you would find that the solution for a is 2 over e cubed minus e to the minus 5. This can be written slightly neater and clearer as 2e to the 5 over e to the 8 minus 1. So I've times top and bottom by e to the 5, and therefore b would be the negative of a, which is minus 2e to the 5 over e to the 8 minus 1. And that gives us our particular solution, our unique particular solution of y equals, I'm going to pull out a common factor to make it as neat as possible, and we'll have e to the 3x minus e to the minus 5x. Remember, b was the negative of a, and that is our unique particular solution, and it's the only solution that will satisfy the original second order differential equation and satisfy both of the boundary conditions that we were given. So looking at the situation here, we had one set of boundary conditions which gave me a plus b is 0. We had another set of boundary conditions which gave me the second equation in a and b, and solving those very carefully for a and b allowed me to write down the particular solution. Notice, pulling out the common factor, I've pulled out a as a common factor, just made that particular solution a little bit neater as well. So here we can see the solution curve, and it satisfies the differential equation and both pairs of boundary conditions. And notice this solution goes through the origin because we were given when x is 0, y is 0, and it goes through the point 1, 2 because we're given when x is 1, y has to be 2. So in the next video we're going to be looking at the auxiliary equation with repeated roots.